Hello, everybody.
Hey.
I am so happy to be here. This is the culmination of a bit of a fairy tale journey over the last 18 months. Some of you may have seen either of us talk about this product in that time, but before then it wasn't a product. It was just something that we did in the evenings in our spare time. I am Damien Edwards. I'm a program manager on the ASP .NET team, and this is
David Felder, developer on the ASP NET team.
And about 18 months ago, we started working on a side project which has gone through a few names in the first few weeks, but we eventually settled on this thing called SignalR. Who's heard of SignalR? Wow! Woo! That's great.
Awesome.
So it's a full room. There's about 750 people here, so it's great to hear so many people. But I can very proudly say today that the title of the talk is Building Real-Time Web Apps with ASP .NET SignalR. So you would have seen in the keynote Scott Guthrie showing off SignalR as part of the ASP .NET Fall Update Preview, which you can download now. And I'm really looking forward to showing you what we've been working on and talking a little bit more about the release that we just made yesterday and what our plans are for the future. So, without further ado, let's go. Now, you all know what SignalR is, apparently, but bear with me, because there are people watching on the cameras. So what is ASP .NET SignalR? Well, it's all about the real-time web, UI that updates in real time in your browser, not something that you may be particularly familiar with if you've been a web user for the last 10 to 15 years. Server push is another term that you use, or you may hear, pushing messages from the server to the client rather than the standard request-response paradigm that we're familiar with as developers and users on the internet. You may have heard the term Comet. Comet is a collective umbrella term that sort of encapsulates a whole bunch of techniques for doing push over HTTP. HTTP streaming is just another name for Comet. The idea of streaming content over HTTP, again, rather than the standard request and then response. WebSockets. Who's played with WebSockets? Just a few people. Part of HTML5, been a working standard for a while now, got ratified finally this year, and we have great support in IE 10, all modern browsers, in Azure now, in the VMs, and very soon in cloud services, for using WebSockets. It's fantastic, and it's a full duplex real socket from the browser to the server that's established over HTTP. So the promise is it works everywhere, but as we're going to see, it doesn't really work just yet everywhere, that is.
Is everyone then polling, like manual polling for their servers and their apps? If you have, that's kind of old school. We're bringing techniques to the table to make it abstract from you. So you just write code as a connection, and it'll just work with whatever transport is required to make it work in all browsers.
Absolutely. So we've seen the term RT a lot. I've got this little thing over here on this left-hand side. Marketing wanted us to use the term RT in our product, so we came up with the real-time runtime for .NET, RT squared. No, I'm just kidding. We didn't do that. But let's just look at some code. Let's go back to the desktop. I'm going to start a new instance of Visual Studio. And I'm just going to create a brand new empty web application, ASP.NET 4.5. It's empty. I'm going to come over here, and I'm going to use NuGet. Let's manage my NuGet packages, and I'm going to go out to the live feed, a bit risky, and I'm going to look for Microsoft.ASP.NET SignalR. I'm going to type it in properly this time. There we go. It's the sample. There it is. I'm going to install that. That's going to install a moderate amount of packages. I'm going to accept a license agreement. That's how you can tell that we're really a Microsoft product now. There's an extra dialogue in the install step. OK. So what did that do? If we come over to my project, you can see we've had some stuff that's been added. I've got a scripts folder, which is full of scripts. I've got a signaler.sample, and I can see a file called stockticket.html. So let's have a look at that. I'm just going to browse that in my browser, funnily enough. Let's open that up. Let's pin that one over here. Let's open up another. Let's open up this one over here. Let's put that one in there. Let's pin that one to the side. OK, so I hit open market on the right-hand side, and we see both sides start getting updates. And you can see that they're in sync. I'm getting broadcasts from the server to the client, and the client is updating. I hit close market here. Watch the buttons over here. And it breaks on stage. Beautiful. Great demo. Thank you very much. Ooh. So let's go and build something from scratch. So that's a sample you can pull in. Let's build something from scratch, because I trust something I build from scratch. Let's call it Move Shape. I'm working over in Solution Explorer at the moment, so let's go and add some server-side code. Now, we actually have, one of the new things that we have is item templates. So if I come into here, And if I'd installed the full preview, you would have seen I have item templates here for SignalR. So if you want to get started with SignalR, you can use item templates now. But I'm just going to start with a class. And I'm going to call this thing MoveShape. I'm going to call MoveShape Hub. And I'm going to derive from something called Hub. So I just imported the namespace up there, microsoft.aspnet.signalr.hubs. And I'm going to add a public method on this thing. So I'm going to say public void MoveShape. And it's going to take in an x coordinate and a y coordinate. And then I'm going to tell all clients who are currently connected that something just happened. So I'm going to say clients.others. So I want to talk to people other than the person who just called this method. And I'm going to say shape moved. And I'm going to put in my x and my y. Okay, so there's my server-side code. That was pretty straightforward. Let's add some client-side code. So I'm going to come in here at a JavaScript file. I'm going to call this moveshape.js. And I'm going to drag in some files. I'm going to need jQuery for IntelliSense. I'm obviously going to need SignalR. And I have to come back in here and add another NuGet package. I'm going to add jQuery UI, which is just here. OK, let's pull that in as well. So I've got jQuery UI. Let me drag that in. And then I'm going to do some standard sort of JavaScript programming here. I'm going to pass in a function to the jQuery constructor, which is going to run on when the page loads, body on load. So now what I'm going to do is grab a reference to this server-side stuff. So I'm going to say, OK, my hub is equal to $.connection.moveShape. So we see I called this thing over here MoveShape Hub. I'm going to attribute this. I don't actually want the word hub appearing in my name on the client, so I'm going to actually put in here MoveShape. Okay. Come over here. So MoveShape is going to be my hub. And then down here, I'm just going to store a variable, which is going to be the HTML element that I'm going to actually manipulate as part of this demo. So we'll call that shape. The next thing I have to do is add the client-side function that my server code is calling. So if we flip back over here, actually let's pin this into some vertical tab groups so we can see this. And we'll just bring this out here. So we've got on the server, I'm calling a method called shapeMoved on my client. So let's add that. So we'll say hub.client.shapeMoved is equal to a function that takes an x and a y coordinate. And then inside this function, I want to go ahead and move that shape on the screen. So I'm going to say shape.css, and I'm going to go ahead and change that to move the thing around the screen using left and right. So I'm going to say left is equal to x, and top is equal to y. So that's going to work. That's nice. So now I have to go ahead and start this connection, and so I can get messages from the server. So I'm going to say $.connection.hub.start, and then when that's done. So I'm using a jQuery deferred promise object here. Start is async, and then the done callback is going to get called when the connection has started. I want to go and wire up the client-side behavior so that I can actually let the user move the shape around the screen and call back to the server to tell them that something has happened. So I'm going to say, OK, my shape is draggable. That's the jQuery UI draggable function. And I'm going to say when the drag event happens, I have to tell the server about this. So I'm going to say hub.server. And what's my server? It's called MoveShape. So let's call MoveShape. And I have to pass in x and y. So this, in this context, is going to be the HTML element that raised the event. So I know that the x is going to be this.offset left. And I know that the y is going to be this.offset top, or 0 if that's nothing. OK? And so that's my client-side code written. Let's come back and actually add an HTML file now. So let's do that. We'll call this index.html. OK, so I'm going to pin this back open. Let's close that one out. And let's add all these files that I need. So I'm going to have to add all this JavaScript. I need jQuery. And I need SignalR. And I need jQuery UI in here because I referenced that as well. And I also need a special script, which we'll talk a little bit more about later on. This one is going to be a SignalR/hubs. And then finally, I need to add the script that actually has this logic in it, the MoveShape script down here. So let's add the shape that I'm going to move around on screen. Call it shape. And let's finally add some style so it looks like a shape. So we'll say shape. And we'll say, let's give it a width of 100 pixels, a height of 100 pixels, and we'll give it a background color let's have a look. That blue looks nice. And we can make the cursor across a move cursor. There we go. Let's see if that builds. OK, that builds. That's a good start. Let's view this in the browser. See if I have any errors in my console. No, it looks pretty good so far. So let's open up a second browser, and we'll move that over here. Oh, that's nice. Thank you. Let's launch that twice.
It is alpha, so.
I don't think we're crashing IE.
Of course not.
There we go. And so as I move this around now, you can see it moves on both sides. As I move from one to the other, it's keeping it in sync in both sides of the browser. So what was that? That was maybe 7 minutes of coding, going from absolutely nothing, starting with NuGet, and I've very easily built something that has a real-time connection, and I have 2 clients that are different browsers talking to each other in real time as things are going on the screen. Pretty cool. So let's revisit this. What is ASP.NET SignalR after all of that? In its essence, it's a real-time persistent connection abstraction over the top of HTTP for .NET. That's all it is. So WebSockets, server-sent events, forever frame, AJAX long polling, these are all techniques you can use to get the perception of a real-time connection. SignalR sits on top of those techniques so that you just code against SignalR and it takes care of everything else for you. And we have 3 pillars that we kind of align all of our features into when we're building this product: simplicity, reach, and performance. These are the 3 things that we think are really, really important when building a real-time web framework.
So real-time isn't just chat. People always ask me, what is SignalR good for? They obviously chat demos, and they always say, OK, chat is cool, but what else can you do? And you can do a lot of things. There's an app called Logger that's built a dashboard. So when users go on their page, you can view in real time people that are viewing your page. You can make anything collaborative. Take any process like Google Docs, take SkyDrive, take anything, and add connections to it, and you can have people all talking to the same connection. You can show real-time job progress. You may have a long-running task on Hadoop or some process. You can show progress at that thing.
Actually, so Guthrie showed something like that in the keynote, where he used SignalR to get real-time updates for on an encoding job, I think it was, from a worker role.
Yeah. Real-time forms. Have you ever filled a form out where you had to enter some data, and then you hit save, and it would say, oh, someone just made a change? So think of it if you had a real-time form. So as you edit fields, you'd see someone in real time changing the field, and it would show up as disabled, so you couldn't edit at the same time. And gaming is a huge one. We have a game demo for you guys today. Shooter.
So shooter.signalr.net.
Yes.
So Fowler's going to go off and start playing a game, and I'm going to talk a little bit about this. So one of the guys on the SignalR team, we actually have a team now, isn't that great? The SignalR team. One of our recent university hires is a game nut, and he's built this amazing HTML5 canvas game hosted in Azure called SignalR Shooter. And so it's running up on a extra large VM in Azure, Windows Server 2012, so it supports WebSockets. You can see Fowler's flying around here. He's shooting against CPU. Oh, there's Taylor. That's the guy who wrote it, Taylor Mullen, right there. So I think he's trying to protect. I think his job was to ensure Fowler doesn't die on stage.
Oops.
Oh.
Friendly fire.
OK, so that didn't work out. So this is a great example of the type of thing that you can do using modern APIs in the browser. Who was in Scott Hanselman's talk this morning? Where he talked about the browser. Great, fantastic. We talked about the browser being the other VM that people perhaps aren't realizing yet. Look at this. This is a hardware-accelerated HTML5 canvas game using SignalR and ASP.NET on the server, sending down updates at 25 hertz from the server to all clients with full client prediction, interpolation, correction, authoritative state on the server. So you can't hack it on the client and say, oh, I'm actually at this position. The server won't let you do that. Everything is running on the server. So we have a game loop running on the server, a game loop running in the client, and everything is kept in sync via SignalR. So we invite people on the stream to jump up and hit this now. It's at shooter.signalr.net, SHOOTR.signalr.net. If you have a Surface or a touch device, it does support touch. So you can load it up on your Surface in the audience if you like. Wi-Fi willing, and you just use your 2 thumbs on the screen. You'll see some green circles get drawn that let you control the ship and fly it around, and then just tap to fire. We'd love to see hundreds and hundreds and hundreds of people end up on this game right now. I think at the moment it says there's about 40 people on there, and a bunch of those are CPU bots. And we do have T-shirts. So during the talk, I'm going to ask some questions, and at the end, I'll ask some more. And if I think your question is great, or you correct the demo that we stuff up, I will give you a T-shirt.
If you kill me, you get a T-shirt too.
If you kill Fowler, you get a T-shirt.
Which
very,
is
very cool.
Oh.
So that's Shooter.
Does it work on the phone?
Does it work on the phone? Yes. Windows Phone 8. We tried it on an emulator. The truth is, we don't have Windows Phone 8 just yet. You guys have got it all before we did. So we did test it on an emulator, and it worked.
It works.
If it doesn't work on your device, we don't have a device yet, but we would love to know if it does. It also has remote control capabilities. So if you have a phone and you have a Surface, you can log into it on your Surface, then load it up on the phone and go to shooter.signalr.net/controller.aspx, log into that with the same Twitter handle or Google account, and then you can use your phone to be the controller and fly it around on the screen. Pretty cool stuff. OK, I think that's enough playing games.
Ah.
I know, I'm sorry. Do you have any other games that people have written to show?
I actually wrote a game called Bomberman. What's the name of this thing? Defaulter VM.
.cloud app?
Yes.
So there's some really good guidance coming out about writing these types of applications. We used an article that I know Hanselman tweeted a while ago about some of the logic required. So this is really interesting. This is like in debug mode. You can see that the ghost is actually what the server is currently seeing as the position of that player. And you can see how over time, there's latency obviously inherent in the network, and then it catches up to where he is on the client. So we use this to kind of look at how we can do prediction in the client, so we can get a nice smooth gameplay in the client, and then correct as the server actually sends down the authoritative updates over SignalR. And he just blew himself up. Very nice. Any other games? One last one?
It's one more, built by a guy in the UK.
So here's one built by a community member. You pick a character, and it's a bit like an old Zelda sort of thing. You sort of walk around, you click, you can talk to other people who are on here, so this is multi-user as well.
Or myself.
Or yourself, because there's no one else in there at the moment. Preview.silverchip.co.uk. Very, very cool. So this is not just about chat. Not just about chat.
But there is chat.
But there is chat as well. In fact, we wrote a chat app. Maybe we should show them that.
Right now?
Jabber.
Oh, yes, Jabber.
Yeah.
Do you guys use Jabber? That's not, again. Do you use Jabber? Yeah.
Yeah. So this is a multi-user chat application hosted in Azure, written on SignalR, open source. The source code is up on David's GitHub repository. And we use this to provide real-time support to people in the community. We're not the only people who use this. There are other teams at Microsoft who are using this to provide support, and not just Microsoft. I know Append2 have used it. Monkey-Space. So and there's actually a build-win room right there I can see now.
Yeah.
Maybe you should be careful about... Yeah, there you go. Very nice.
Oh, no. Let me stay out. Safe for work. Safe for work.
Safe for work. OK.
Awesome.
Very good. So we can do more than just chat. So after I've said that we can do more than just chat, let's do another demo. Yeah, let's do another demo. So let's start out by, I mentioned these 3 pillars: simplicity, reach, and performance. Simplicity, reach, and performance. So when we talk about simplicity, what do we mean? We talk about the API. So SignalR uses a very simple 2-level API. We have a low-level API called connections, which is about sending raw strings up and down. If you've ever done socket programming, it's a little bit easier than socket programming, but not much. You're sending raw data up and down. You have to manage receiving stuff off the wire. You have to frame it yourself. You have to do dispatching yourself. Both client and server have to agree on what's going on. But we do give you a little bit more. We give you connect, reconnect, and disconnect semantics.
And negotiation, so you get follow-up to WebSockets, long polling, the same stuff that you get for
We'll have a look at that a little bit in just a minute. And you can also do broadcast. So rather than just being a point-to-point connection, we have the concept of, well, I'm connecting to this endpoint, but I also know about everyone else who's connected to this endpoint, so I can broadcast to everyone who's on there. And I can slice the connections up into groups, so I can broadcast to individual groups. But on top of that, we have a high-level API called Hubs, which is what I showed you in the first demo very, very briefly. And this is where we expect most people to spend their time. It's built on top of our low-level connection API. And what it enables is this illusion of RPC, remote procedure call, from the client to the server, which we've all seen. I mean, every web service technology lets you do client-to-server RPC. But critically, server to the client. So you saw in my first demo how I went client.others.some method name, and then my JavaScript function got invoked to move the shape around the screen, which is really quite amazing. And then the JavaScript client in particular, we had this automatic proxy generation. That was that magic URL I put in that I said we'd look at a little bit later, /signalr/hubs, that actually generated JavaScript on the fly that had those methods that represented the server-side methods that I could call. And of course, you can just choose the level of abstraction that works for you. You may not like, if you don't like our Hubs API, you can build your own on top of the raw connections. That's totally fine. So let's build something else to compare these two APIs to each other. So here's my move shape demo. Let's build chat from scratch, because we know we all want to see how to write chat. Let's add chat. I'm going to do the same thing I did before. But this time I'm going to use connection. So I'm going to add a new class, and I'm going to call it chat connection.cs. And I'm going to derive from persistent connection this time. Persistent connection. So you can think of the persistent connection class a little bit like the ASP.NET HTTP handler class. It's a low-level class used for our persistent connection abstraction. It gives you all the transport negotiation and all that goodness. Now, I also have to add some code to my application so that it knows what URL is going to map to this thing. So let's go into, I've already got a pre-app start method here. So let's add some routing in here. So I'm going to say our route table.routes.map connection. And I want to map to my chat connection. So this is very similar to what you would see in Web API or MVC. And I'll just give this a name. This is my chat. And the URL will just be chat.
You need the slash.
And I need on the end of it a catch-all. So that's going to be asterisk operation. OK. So what's going to happen is the SignalR client, which we'll look at a little bit more in a minute, is going to use this URL to talk to the server. OK, so now I have my thing. I can override a bunch of methods on here to do various things. So you can see we have some on-disconnected, on-connected. They're our connection semantics. And we have on-received. So that's when I'm going to get messages from the client. So that's what I want to override here. So when I get messages from the client, I want to go ahead and broadcast that out to everyone else who is listening. So let's come in here and we'll say connection.broadcast. And I want to broadcast out the value that got sent up by the client. So that's just going to be data. And that's my server-side code.
Return it.
Oh, and return that because it's task returning. So SignalR is asynchronous from the client all the way through to the server. So you'll see tasks used everywhere. So you have to ensure that you always either return a task, or if you're using 4.5, if you're doing something synchronously, you can always return a completed task using something like task.fromResult. So let's add our client side like we did before. Let's add HTML file, index.html. And let's add some UI here. So we'll do an input, ID equals message, type equals text. Then we'll do input, ID equals send. And then we'll do type equals button. And we'll do value equals send. And then underneath that, I need somewhere to put the messages from the server. So we'll say ID equals messages. And I'm going to add messages to there as I receive them from the server. So let's add my script again. I'm going to need jQuery. I'm going to need SignalR. And I'm not using hubs this time, so I'm just going to go ahead and start typing script directly in here. Similar thing to what I did before. So when jQuery has told me that the page is finished loading, I'm going to go ahead and create a connection and start it. So I'm going to say var con equals $.connection, and I have to pass in the URL to where I want this to go. So we said my URL was just chat. And I could put /chat in here if I want. So that's good. Then I want to wire up a handler so that when I receive stuff over this connection, I update my UI. So let's have a look at the IntelliSense here. Con.received. I have to pass it a function that will take in the data that I just received from the server. So very standard sort of JavaScript client programming here, very similar to using Ajax, where you make a call, then you pass a delegate in or a function in order to be called back. And so when this happens, I'm going to get my messages, HTML element, which I called messages, and then I'm just going to append a new message to it. And it'll be an li. I'll just do some poor man's templating here. You all do this, right? Beautiful. Who needs templating? And then I'm going to go ahead and start my connection. And again, that's asynchronous. So when that's done, pass another callback in here. We love callbacks. Now, some of you might be wondering why I'm chaining this stuff on to the start method. Now, I could, at this point, wire up the button click handler here underneath this one here. But that introduces a race condition in the UI. And you may have seen before where a page is loading and you start interacting with the page and nothing happens because it hasn't finished loading all the script. So this is just a good pattern to get into when doing this type of asynchronous connection programming. I'm not going to wire up the client-side behavior until the connection is actually started. So the user can't start clicking things and seeing nothing happening. So let's go ahead and do that. Message.click, when that happens, I need to grab the message from the text box. I need to send that to the server. So var message is equal to message.val. And then I'm going to say con.send. And I'm going to send through that message. Pretty straightforward. So thank you very much. T-shirts for the 75 people who corrected me in that demo. I wish I had 75 T-shirts to give out. OK, so let's view this one up in the browser. What was that, sorry? I'm not. I could. I mean, this is a very simple demo. So I should be able to see it echo back to me now. So there it is. That's going up to the server. And then the server is receiving it and sending it back to the client. You notice I didn't do any addition based on the button click in the client. So I can start another browser here so we can see it in 2. So I can say, from Chrome, send, and that one comes from Chrome. So very, very, very easy to do. But that was with connections. The problem with connections is that as soon as my application gets any more difficult than just sending one type of message back and forward, I have to do stuff like this. So perhaps I wanted to add a button that just echoed me. It didn't go to everyone. So let's add a button called echo. Let's add a second handler in here, echo. But the problem is the server doesn't know anything different about these messages. It's just seeing a message. Well, my code at the moment has no logic to distinguish between an echo and a broadcast. So I have to go back to my server. And now I have to do something like, well, if data starts with echo colon, then I'm going to do return connection.send. So I'm going to send it back to this person who just did this and just send back the data. Else, I'm going to do the broadcast.
You got to pass in the connection ID.
And I have to pass in who I'm doing it to, which is this dot connection ID.
It's a parameter.
To?
Right there.
Connection ID.
Yeah, ID. So I'm a dev.
So that's how you know. That's why we have devs on stage to help the PMs. But this isn't very nice. I mean, all I've done is add one extra function. Now my code is full of switch statements and if statements. So there's a much, much nicer way to do this. And of course, I haven't even updated the client yet. I haven't come back in here and appended this with an echo, colon, and all the rest of it. So this is what hubs is really, really good. So let's convert this into using hubs. Let's come back in here. Let's add a new class, which is my chat hub. Let's make this derived from hub. Now I'm just going to add 2 methods. Public void send string. We get typing as well, which is kind of nice. Public void echo, which also takes the string. And in this one, I'm going to say clients.caller.newMessage, pass in the message. And this one, I'm going to say clients.all.newMessage, and pass in the message. Okay, very, very simple. And then back in the client to change this, so no longer am I using a connection. I have to add that special script that we saw before. So SignalR/hub. So that's going to bring me my client-side hub proxy. Change this to connection.chatHub. Okay, because my server-side class was called chatHub, it's going to be called chatHub on the client. And then rather than this, I have to say connection.client.newMessage is equal to a function. Is equal to a function And that function adds it in. And down here, after I don't want to start this connection anymore, I want to start connection.hub, which is the single hub connection that we create for you over which all hub traffic travels. And then now I can simply say when I click the send button, I'm going to send, let's rename this to chat, just so it's a little bit clearer. I'm going to say chat.server.echo. Oh, that was actually send. And this one will be chat.server.echo. Okay? So now you can see how we get this nice call methods on the server, and we get the nice typing in my server-side code. So we'll just JSON deserialize everything that goes over the wire. So if you send a JavaScript object, you'll get you can actually take in a JToken or a dynamic object here, and we'll do that for you.
Or a type.
And the other way, or a type even, and we'll deserialize into a type. And the other way, you can send objects from the server, and we'll get a nice JavaScript object on the client as well. Okay, so that's connections versus hubs. So that's simplicity. We think it's a really nice, simple API. So what about reach? I talked about WebSockets in the beginning. WebSockets are fantastic. They really, really are. Huge advancement in the technologies that we have available to us as web developers and web users. But they're still relatively new. So WebSockets work, for an ASP.NET developer, they work if you use ASP.NET 4.5 and you're on Windows Server 2012. It's actually an operating system feature at the server level. It's an update to IIS and the underlying HTTP sys kernel driver to support WebSockets, so you do need to have Server 2012. And your client is using IE 10, which means at the moment they have to have Windows 8. Or they're using the latest versions of Chrome, Firefox, Safari, Opera, choose your favorite browser. And all the network infrastructure in between the client and the server is not going to get in the way of a persistent socket connection. I mean, a lot of proxy servers still don't allow anything but standard HTTP traffic, and they actually trounce on top of WebSocket connections. And this isn't just the client-side proxy, it's also the server-side reverse proxy. It's client-side routing with things like NAT and server-side routing as well. And you're happy coding against raw sockets. I mean, if you've coded raw sockets, you're essentially sending bytes or segments of bytes, and you're responsible on the server for having an asynchronous receive loop that keeps calling receive, checking, adding it to a buffer, checking if you have enough in your buffer to actually formulate a proper frame, decoding it from the wire format into the format you expected, like UTF-8, and then dispatching off to actual code. No one wants to do that. And in ASP.NET 4.5, it's exactly the same. They're very, very low-level APIs. And then when it comes to scale-out, WebSockets is a point-to-point connection. That's all it is. So if you want to do things like broadcast to multiple users, you have to keep a collection state on your server so that when someone comes in, you say, OK, broadcast, you have to enumerate over all the connections that you've stored and then broadcast to each one individually or send to each one. And if you scale out to multiple servers in a web farm, you've got 1,000 people connected to one server, 1,000 people connected to another with WebSockets. How do they talk to each other? You have to manage that scale-out yourself. SignalR, on the other hand, works everywhere. So we'll try WebSockets. Now, I'm running Windows 8 here. Shooter is running on Windows Server 2012. So as long as you're using a client that supports WebSockets and the network allows it, we'll use WebSockets. But if it's not available, we'll fall back to server-sent events, otherwise known as event source. It's an API in all browsers but IE. It's a fairly old standard that wasn't widely implemented and used that allows you to stream data from the server to the client over one open HTTP connection. It actually has a JavaScript API. Then we use Forever Frame in IE, lower versions of IE that don't support sockets and server-sent events. Another technique that's been around forever, you have a hidden iframe, streams down script blocks into the iframe. It's really nice. Browsers will execute JavaScript as it arrives from the server. So you can have a hidden iframe that just does nothing but receive script blocks that has function calls. And now you have your messages coming into the browser. You do cross-frame messaging. And then we have the very low level, which is long polling, which I think David mentioned before, which you may have used polling in your applications before, Ajax polling, where you just poll the server every 5 seconds or 10 seconds. Most of the time you get no data, but then you get data on like the third one, and then you have to wait 10 seconds if there was more data in the meantime. Long polling is I open a connection to the server, and it stays open. It's an Ajax request. It stays open until there is data to satisfy that request. Then it returns, gets processed in the browser, and then it makes another call immediately until the next round of data comes. Works everywhere. I mean, so that's why it's the lowest common denominator. We also give you a great API on top that I just showed you. We do our best to keep that connection open. So if the transport fails, If you pull the network cable out, you close your lid, you open it again, you go through a tunnel, any one of those things, it'll go into a reconnect loop. And it'll try and reconnect, and it'll raise events on the client so that your application can show messages, have custom retry logic, whatever it is that you want to do. But we'll do our best to keep it up. And we support scale out in web farms, so that you don't have to do it yourself. Cool. So Fal's going to show you some transport negotiation.
So I used Damien's chat demo that he showed earlier. This one. All right. We'll look at the network tab. If you use SignalR, install JavaScript, the client-side APIs, so get used to living in the developer tools for each browser. So I'll go to the network tab and start capturing. And I'll hit F5, and you will see this negotiate request.
Zoom in a bit.
This is there we go. So the first request is a standard AJAX post. We send a request called negotiate to the server side. That request contains, the response contains, the URL to the connection ID. Each connection has a unique ID. So when you open multiple tabs or multiple browser instances, you get different IDs. And you can't share them across multiple tabs.
It's actually a really common question we have is, like, does the connection live across browser sessions or across tabs? And no, this is just
JavaScript calling your browser.
JavaScript calling the server. It's either an AJAX request, or it's server-side events, or it's WebSockets.
Yeah.
It's still JavaScript. If you hit F5, that connection goes away, and you get a new one. And so you have to manage that on the server-side code in your application to know that, well, David Fowler is currently logged in on connection ID
1, 2, 3, 4.
that good.
Yeah.
And you have to keep track of that in your app.
Yeah, so you map users to connections. So if I'm on my phone in Jabber and I'm on my desktop, I'll have one user, 2 connections, and you can broadcast to all users that way. This flag, WebSockets, is true because I'm on Windows 8 and I'm in IE 10. If I were to flip it to IE 9, you see a different request. Well, it's still true, but I guess it's IE 9. So the server supports it, but the client side doesn't support it. So we get this request called forever frame. If I go back to the summary view, you'll see this pending request. This request will last for a very long time, well, forever, until the connection closes. And when I go back to the chat sample, you'll see it'll work just fine. So depending on your browser capability, if I open Chrome now, I'll have WebSockets here because Chrome supports WebSockets. And it actually shows you frames, so I can actually dig into the request. You see Connect 101, switching protocols. That is the upgrade request to WebSockets. If I go to the response, if I navigate.
I haven't sent anything yet.
There we go. You see frames, and frame shows every frame going
Zoom
in and out to the connection.
So that's the actual WebSocket data going over the underlying connection that SignalR is managing for you. And you can see that's not just the data I wrote in my sample. We're wrapping it with a whole bunch of other metadata that we use to keep that connection open, to manage things like the groups. We also have state that gets round-tripped.
Yep.
We do, if the connection goes down, I said that we reconnect, we buffer messages on the server, so we need to know where the connection was up to. So you'll see in there all these zeros and things. That's cursors that tells the server, hey, I'm coming back, and last time I saw you, I had message 123. Can you give me everything since then?
We're working on compressing this. It's a little big right now. We're working on actually compressing this thing to be pretty small, so it's not in your face and
big.
Taking your bandwidth. As you can see, the outgoing calls are pretty simple. It tells you the hub, the method, and the arguments, and the state. So we build hubs on connections. So when we send stuff over the wire, we just send a well-known format to invoke messages on the server side and vice versa. So in your connection, so the whole point is you have different transports working across different browsers, and you don't have to care about it. It'll just work. Long polling will only be in effect as a last resort. So if you're on like a really old mobile phone or an old browser, or if your client-side buffers stuff and you can't do HTTP streaming, you get a long polling request. So you shouldn't really have to worry about this. You just code your app normally, and it'll just work for most clients.
Cool. Very good.
Cool. Yep, still me. So reach. Let's talk about clients. So right now we have a JavaScript client. It's a jQuery plugin. .NET 4 on a 4.5 client, Silverlight 5, Windows Store apps, iOS, that's community maintained, and monotouch. In the future, we'll have all of these, so you can build apps on.
So obviously, we think frameworks like this are that much more powerful if it doesn't just work in the browser. You can write a real-time web application. And we know a lot of people are accessing web pages from mobile devices, from their Xbox consoles, from their fridges, their iPads, whatever it might be, their Surfaces that they just got given.
Yep.
For free.
You'll get one. You'll get one.
I'm not jealous. I have T-shirts, so there. That you don't have yet. But the more we have, the better it is. The more we have, the better it is. We love clients. We want as many clients as we can.
And we're open source. So
we're open source, so send us a pull request.
We'll take it in.
And Fowler will reject it.
Yeah, most likely. Let's see a mixed clients demo. So this morning at like 7 a.m., I wrote this app. Let's see it in the flow. So I have 3 samples here: a console app, a Windows 8 app, and a web application. And I will do some awesome Windows 8 stuff. You've seen that before? Awesome, right? Yeah. 3 clients.
Oh. What are the 3 clients we have here?
Web, console app.
Console. And a pinned Windows Store app.
Windows Store app.
Get that right.
Get that right, yes. Windows Store app.
Windows Store app.
So I'll connect here, and I'll say, hey, and talk to myself like a crazy person.
Look at that.
Oh,
very nice.
All clients working. Console app is, my UI is better. All right. So for the .NET devs out there, you can. Let's do some awesome. Whoosh. All right. So this for the console application. Have you guys used async and await in .NET 4.5 yet? You should love it.
Yeah, good
it's
stuff.
amazing. Yeah. So the .NET API is pretty simple. You create a hub connection to the URL, the server-side URL. You create a hub proxy. There's no magic URL in .NET, so you have to create a proxy by hand. You get a proxy back, and you handle the on event. Specify the method that the server is going to call up to you. And when that comes in, we're going to call console write line. We await connection start because it's fully asynchronous. And then I read my lines one by one, and when I get a line, I'll invoke send on the server side, and I'll invoke send on my hub here.
So if you get back to that code for a minute, David, it's very similar to what we saw in the JavaScript. The only difference here is that instead of me saying chat.client.send is equal to some function, I'm just having to handle it via a string.
Yep.
So I mean, we're still doing dispatching here, but we're doing dispatching via a high-level API. And so as long as the server is broadcasting a send method invocation and you're handling it here, it'll work.
That's a good point. Let me just show you this thing. It's the magic proxy that Damien showed earlier, SignalR/hubs. It's pretty simple for the most part.
So remember that magic link I put in a couple of those slides, a couple of those demos?
The script itself has very little code. Each of your servers, whoa, it won't go down. There we go. Each of your server-side hubs gets a client-side object, and it's the same API that you saw on the .NET client. So you can use this API by itself without going through the proxy if you don't want to get the magic script and do stuff that way.
And you can generate this script beforehand. Yes. You don't have to do it at runtime via the link. We have an exe that you can run as part of your build process, signalr.exe, funnily enough, that will generate this script for you so you can just compress it, put it on a CDN, whatever it might be.
Combine, cache it,
all that type of stuff.
That's what Jabber does, by the way.
Very cool.
Awesome.
All right. Back to you, sir. Find the PowerPoint. There. All right, so let's look at performance, because that's the next question everyone always asks.
It's fast.
And we're done with performance.
Yeah. Next.
Do you trust us? So when we talk about performance, we talk about 2 things, throughput and scale. We're going to use the word performance to encapture both of those things. Completely rewritten the internals of SignalR for 1.0.0. So who has used an earlier version of SignalR, one of the 0 dot versions? Okay. It was pretty good. Like when we did our load tests, at home on my 4-year-old Core i7-920 desktop, which has an obscene amount of RAM, but that's fine. The RAM doesn't help in the throughput scenario. We could connect 5,000 connections to it using a couple of laptops, broadcast it, a dozen or so messages a second, some amount, and we could peak that at about 30,000 broadcasts a second. So 30,000 messages flowing through the message bus a second. With the new system, we're seeing an 18 times performance improvement on that. So on that same box, my 4-year-old desktop at home, it peaked at 500,000 messages a second. And just as a bit of a tidbit, last night I created an extra large Azure VM. That's the 8 cores, and they're AMD 1.6 Opteron cores. So it's kind of equivalent to my Core i7-920, which is 4 cores and hyper-threaded. Funnily enough, they're almost identical. So I almost got identical performance with an extra large VM in Azure for one box. With so many thousands of clients, I can get anywhere from 250 to 500,000 messages a second because the load is always kind of peaky because the clients have to actually receive the data. Now, the key to doing this is very, very low memory overhead. So that's throughput, but scale is about getting as many connections on the server at once. When we talk about scale with ASP NET, we're really building on top of the great work in ASP NET over the last 12, 13 years here. I have seen a virtual machine running a very early version of SignalR with long polling having 100,000 active connections on one virtual machine. And with WebSockets on ASP NET 4.5, I saw a VM running 460,000 concurrent WebSocket requests that were actually talking to each other on one VM. So ASP NET scales crazily if you configure it correctly. Out of the box, it's set up generically. It's set up for the 80% case of apps, but nearly everything is configurable in ASP.NET. All the queue sizes, the buffer sizes, how many concurrent connections. You can edit all that stuff to optimize it for this type of application as opposed to a standard request response type of application. So one of the key things here is very low memory overhead. SignalR, we do a lot of work, and Fowler does a lot of work, to ensure that we allocate as little memory as possible for a connection, and when we send a message, and when we do allocate, we do it in such a way that Gen 0 garbage collection can clean it up very, very quickly. Gen 0 is very cheap to collect, Gen 1 is a little bit harder, and Gen 2 is really expensive to collect. And so when we do our performance runs, we generally see the ratio of Gen 0. Who's ever done this type of thing before? Am I just talking nonsense, or people have done this? Okay, yeah. Our ratio of Gen 0 to Gen 1 to Gen 2 for our low test scenarios is 1,000 to 20 to 1. Really, really nice ratios. So scale, fully async. You've seen that. Fully async. That's what lets us get all these connections active in ASP.NET at once, because they don't use threads if they're idle. They only use a thread if there's actually something going over the connection, because it's asynchronous. So I talked about the thousands of connections. And then when we need to go beyond one box, because we need to support more scale, or because we need fault tolerance, we do this horizontal scale out using a pluggable message bus backplane. And a PM wrote that line. He wrote that line. So this is your web farm, web nodes. Green boxes are my servers. I have SignalR clients connected down the bottom. You can see the problem here. If I'm sending messages in this little node here, how do they get to the people connected on the other nodes? So we have to introduce another piece here, a messaging backplane. This is no different to when you're using a database. You would have a common SQL server that all your web nodes connect to, and that's how everyone can get the same data, or a common caching service, or whatever it might be. Well, in this case, we have a common messaging backplane. And what happens? Well, a message originates from a client, probably a browser. It goes up to the node that that browser is connected to. From there, the node sends it directly to the backplane. So the key thing about our scale-out architecture is the backplane is authoritative. We don't service the clients immediately in here. We send it to the backplane first. And then the backplane delivers it to all web nodes that are taking part in this cluster. And the important reason for that is such that, and then obviously it goes off to the clients, is that an individual client can flip-flop between nodes because of round robin and that type of thing. And it's always going to be able to get the messages that it missed while it was reconnecting within a tolerance. And you're not going to get repeated messages, because the cursor that we send you back to the client under the covers that says, hey, the client over here is currently up to up to message 1234, and he suddenly flips over to this server, he tells that server, hey, I'm up to message 1234, and that server got all the messages, the same messages from the backplane, so you get every message since then. So what backplane technologies do we support? So as of today, there are none released. But next week, we will be doing 3. The SignalR team will build and support 3. And we've had various versions of these in development over the past year. We have one for Service Bus, whether you're running in Windows Azure or whether you're using the newly released Service Bus for Windows Server, which went 1.0 this week. We have one for Redis, which is the open source in-memory database that Microsoft OpenTech has actually ported to Windows. So you can go up to Microsoft OpenTech's GitHub repository, clone it, build it. It's a C++ app. Just build it in Visual Studio 2012, run redis.exe, and now you have a Redis server. And it's an in-memory pub sub. Point all your nodes at that. And we also support SQL Server, because everybody is running SQL Server if they're on ASP NET. Well, not everybody, but most people. And so it's worthwhile having a sort of a lower pseudo message bus backplane that we know people will already have if they can't deploy new technology into their environment. So look to see NuGet packages for those 3 backplane technologies come out on NuGet next week. So let's talk a little bit about performance. Let's do a performance demo. So we have in the source code of SignalR, let's escape that, this thing. This is the SignalR load test harness. Let's make sure it's still running. It is. This is a little dashboard that we can connect clients to and then sort of get the server to start broadcasting messages to those clients, and also either echo or broadcast messages that the client send to it. So it's a nice way of just standing up a very quick environment and then having clients connect to it. So I actually have a bunch of clients connected to it. I have 3, and there's a link here. I can control-click on that and drag it out. I have this little mini connection client that I have here. We also use WCAT, the Web Capacity Analysis tool, which is an IIS tool that you use to drive load on servers. And in the source code for this, we have WCAT scripts that you can use to drive this test harness. And over here, new for 1.0 alpha, we have performance counters. So we have SignalR performance counters now, so that while you're doing this type of work or in production, you can look at everything going on in your SignalR application, very similar to what you would do with ASP.NET. Now you install these counters using the same executable that you use to pre-generate proxies. We have a signaler.exe that does multiple things, and one of them is install perf counters on your system. So everything is still delivered by NuGet. You don't have to install an MSI. There is just an exe on NuGet in the signaler.utils package. Grab that exe and run it, and then you'll get these perf counters. And so we can see right now, I've got a bunch of connections. So we can see connections current is 5, because I think I have this browser, I have these 3 browsers, and I think somewhere hidden I have another browser, and I have a bunch of other browsers open. So I've got 5. So I can start broadcasting, and what we should see over here is I've got messages received per second is at 5, because I have 5 clients, and I'm sending one message a second to all of them, so I get a total of 5 messages a second. So that's good. And I can come up here and sort of ramp the broadcast rate up and come back over here, and we should see the messages received going up, which is kind of nice. And I can also come down to one of the clients, and I can say, well, I want the client to send a message every 100 milliseconds. So let's do that. Zoom back over here. So now I should be getting messages sent. You can see I'm getting messages that are being sent every second as well. Let's do that on multiple clients. I'll hit go and hit go. So now I've got 30 messages a second being sent from my clients. And then I can change the listening behavior from listen only to broadcast. So now every one of those sends is going to result in another message being sent. And so now we can see that our message receive rate has gone up to 150, the combination of all those different things going on. So as I said, this is the load test harness rig that we use when we get those numbers that I talked about before. Obviously, I'm just running it on one laptop here, so I'm not going to get 500,000 on stage for you. But you can download this source code, set it up for yourself, and see what numbers you get in your environment. Incidentally, we also have in this repository, it's worth showing you, a baseline. So if I go into, this is the source code for SignalR I'm looking at now. I'm over in samples, load test harness. We have a baseline folder that includes just 2 standard ASP.NET handlers, a basic.ashx and a querystring.ashx. And then in the WCAT folder, we have the scripts that you can use to drive the WCAT load test tool against both the test connection and those handlers. The reason we have a baseline is that it's always a good idea to do a baseline run of your server with just pure ASP.NET. Just hit a handler that does nothing but say hello world to get an idea of how, what sort of throughput you can get on that server. So for instance, my server at my machine at home, I was getting the 500,000 peak on, can do about 25,000 ASP.NET requests a second when those requests are just doing hello world. So you can sort of see the ratio of difference between a standard full ASP.NET request versus streaming data from the server over an existing connection. You get sort of 20 times the throughput, which is kind of nice. OK, so you can grab those right now out of the source. So new features for Alpha 1. Improved performance, we talked about that. Revised client invocation API, you would have seen that. Hub authorization, this was an oft-asked-for feature. You can now use the hub authorization attribute to say that this hub requires a person to be authenticated or they must be in this group, and you can put it on individual methods as well, much like you can do an MVC with the authorization filter there. That's built on top of a new hub pipeline. So you can now plug into the hub pipeline, very much like action filters in MVC, and get your code running before the actual method on the hub gets invoked, or as a message goes out from the hub to the client. So you can build things like tracing, you could do model binding, you could do all types of interesting stuff with the pipeline modules. We also have client-side keep alive. So now the client keeps track of messages coming over, and if it detects that the connection has gone idle, the keep alive packets aren't coming through, it'll raise an event in the client code, which you can handle to show the user perhaps that the messages are becoming unresponsive, or the connection, sorry. And then after another threshold hits, it'll actually forcibly stop the connection and restart it again. So lastly, it is host agnostic. I talk about ASP.NET, but like Web API, you can actually run this on top of your own self-host as well via OWIN, the Open Web Interfaces for .NET. It's cross-platform. We do have people using this on Mono. They take our source code, they compile it. Now they can run ASP.NET with SignalR on top of Mono, on top of OS X or Linux. And we're open source. We're the #1 watched C# repository on GitHub. Woo. Thank you. We are a supported part of the ASP.NET family, or I should say we will be when we hit 1.0. I mean, we're still in alpha today. You can go out to NuGet as of today, install SignalR 1.0 Alpha 1, and once it hits 1.0 RTW, you will be able to get support. It's part of the ASP.NET product suite now. And speaking of 1.0 Alpha today, we will do an Alpha 2 in a couple of weeks. We're going to do questions in a minute. And we're going to do a 1.0 RTW by the end of the year is our current target. So you can get more information at signalr.net. Here's our emails, Twitter handles, that type of thing. We've got 2 minutes, 3 minutes to take questions. But thank you for coming if you're going to leave now, and I hope you enjoy it. Now, the microphones are here. Feel free.
Help. Do you want me to see how?
What's that?
Do you want me to? There it is.
There it is.
How tamper-proof is the messaging going back to SignalR? Obviously, you have authentication for security, but what about somebody sending poison data back to the hub?
That's a very good question. So, like anything going over the web, I mean, if your data is sensitive, you should be doing it over SSL, so you know it's not going to be tampered with on the way. Other than that, it's your client, like your code sending to the server, or it could be a malicious user sending stuff to the server. But obviously, we'll do our best to ensure that people can't bring down the server by sending malicious payloads, just like we do in ASP.NET. But beyond that, that's an app concern. So, but we do support authorization. So if the client is authenticated using a cookie, and the underlying server, like ASP.NET, will flow that up on the thread as the principal, we flow that user principal all the way up to the hub. And then you can use the authorize attribute to restrict what methods can be called.
Okay, great, thank you.
Oh. T-shirt.
Oh, yes, come and get a T-shirt.
Hello?
Next person.
Over here? Over here, maybe? This side. Damien, over here. Is there any truth to the rumor that SignalR's inception was you guys trying to run your train sets while you were out on the road?
What? Train sets?
No, there is no truth to that rumor.
Okay, seriously then. I can just grab it, run it on, put it on my machine, deploy it to one of my 10 free Azure websites, and it will work.
Yes and no. So there's an issue with Azure websites today that is being resolved very soon. Long polling works on Azure websites, but the streaming transports don't. That will be fixed in the coming months. And I'm told WebSocket support will be coming to Azure websites very soon as well.
Thank you.
So I have a question with performance.
Okay.
Over here.
Yes.